All right, welcome to the last lesson in Chapter 7, 7.6, Solving Rational Expressions. All right, so by the end of this lesson, you should be able to simplify rational expressions and identify any excluded values. You should be able to multiply rational expressions and divide them. So we're going to start off with example 9. Solving a rational equation by cross multiplying. So whenever you have two fractions that are equal to each other, you're able to do cross multiplication. This gets confused easily with multiplying and things like that, but so the key here is the equal sign. Whenever you have an equal sign, you're saying that two equations are equivalent, you can cross multiply. So what does that mean? That means that we can multiply those two together. Let me get my words working today. And then we're going to multiply these two. So the ones that are diagonal from each other. All right, so write original equation. I mean, that's a given. Then we're going to cross multiply. Sorry if you hear some barking. There's a lady walking down the road, so I may have to sporadically pause the video. Okay, so we're looking at it this way. So another way you may have learned it is like this. But we're just going to go ahead and dive into it and cross multiply. So we got 3 times 4x plus 5. So 3 times 4x plus 5. And we're going to set that equal to the other side. So 9 times x plus 1. All right, and then we're going to use distributive property. So we're just multiplying. You guys should know this by now. You're just multiplying the outside number to the inside. So 3 times 4x gives us 12x. 3 times 5 gives us 15. 9 times x gives us 9x. And 9 times 1 gives us 9. So now you have a multi-step equation. All right, everybody should be able to do these. You've been doing these since 7th and 8th grade. So what do we do first? You need to get your variables to one side. A lot of times y'all start with the numbers. Start with the variables because that will help you avoid negatives whenever possible. So we're going to subtract 9x from both sides. So we're going to do 9x, subtract it there, subtract it here. So it cancels out on that side and leaves us with 12x minus 9x is 3x, and we have 3x plus 15 equals 9. All right, so now we're going to deal with the number because remember, we're trying to get the variable isolated. So now we got to get rid of this plus 15. So how do we do that? We subtract it. So we're going to subtract 15 on both sides. That leaves us with 3x over here, and 9 minus 15 gives us negative 6. Then our last step, we want 1x, not 3x. So how do we do that? We divide both sides by 3. Again, this should be pretty common practice for you guys now. And you get x equals negative 2. So as always, the great thing about equations is you can always check your answer by plugging in the value and solving to make sure both sides equal. So I'm going to actually do that with this one just for the people that want to make sure they definitely have the correct answer. So the way that you would check your work, and I know I don't do this a lot because you can actually do most of this in a calculator most of the time, but just for practice, just so you can check your work, make sure in this situation. So all I'm doing is I'm taking the original equation where x was, I substituted in negative 2, and then I'm just going to simplify. So this becomes 3 over negative 2 plus 1 is negative 1, and then that can change to negative 3 because 3 divided by negative 1 is negative 3. So what we're doing is we're seeing, does this side equal that side? So 4 times negative 2 gives us negative 8. And then negative 8 plus 3 gives us negative 3. So we have 9 over negative 3, which 9 divided by negative 3 does give us negative 3. So these two sides do equal. So that means negative 2 is definitely our answer. So like I said, you can do a lot of this in the calculator. You could set that up and hit enter. You could set that up and hit enter and then just see. You don't have to actually write it all out. All right, so moving on to moving on to the next example. So solving rational equations by using the LCD, also known as the least common denominator. So we did this in the last lesson. All right, so we're going to solve this equation by using the LCD. Well, what is my least common multiple between these two? Well, it's going to be, or actually between these three, my bad. Between these three is going to be 4x. So we're going to multiply. All right, this is going to be a little strange, but I will explain why we're doing it. So we're going to multiply this side by 4x, and then we're going to multiply this side by 4x. All right, so we're multiplying both sides by 4x. Why are we doing that? Because our least common denominator is 4x, because you have an x, a 4, and an x. So your least common denominator is 4x. That's why we're multiplying both sides by that. So what happens is when we multiply the top by 4x, we're really just distributing to the top. So I want to show you what this looks like. It may be more steps than you will need when you work it out, but just to explain it as easy as possible, I'm going to show you what we're doing. So we're kind of doing distributive property, but remember, when you have a whole number, you only multiply it to the numerator. So 4x times 5 would give me 20x over x. All right, then 4x times 7 would give me 28x over 4. Okay, then on this side, I'm going to do the same thing. 4x times negative 9 would give me negative 36x over x. So I didn't want to skip this step, but in the future, yes, I'm okay with some of you skipping it. Remember, when you have bases that are the same, they can be divided. So essentially, I can divide out those x's. It leaves me with 20. Now, this one I don't have x's to divide out, but I do have numbers. So 28 divided by 4 gives me 7, and then I have the x. Okay, so 28 divided by 4 gave me 7, bring the x down. And then this one again has x's, so I'm able to cancel those x's out, and it leaves me with negative 36. So if you look at any examples on big ideas, it's going to go from this step straight to this step. All right, and this from here, you guys should be good. This is a two-step equation. All right, so what do? We need to get rid of this 20 so we can get x by itself. So how do we do that? We subtract it. So that leaves us with 7x is equal to negative 56. All right, then we don't want 7x's, we want 1, so we divide both sides by 7, and we get x equals negative 8. So our solution is x is equal to negative 8. Now you can go back and plug in negative 8 for both of these and see if it works. All right, you will have to make this an 8 as well, so that would become 14 over 8. But you can do that. You could also put it in the calculator so it will do all the work for you. If you want more on how to check your answers, just talk to me. We can work some out together. All right, let's look at part B. So part B is a little different because we have a whole number, then we have this, and we have this. But remember, a whole number is the same as anything over 1. So if you want to look at that as a fraction, you could think about it as 1 over 1. All right, I'm just going to let it be for now. So we're looking at our denominator. Again, remember we need the LCD, our least common denominator. All right, in this case, we have an x minus 5 and we have an x. So we're going to make that our least common denominator. I'm not going to multiply these together yet. All right, I'm going to leave it like that. So now we're going to multiply both sides by x times x minus 5, kind of like we did right here. All right, so now we're going to do just like we did over here where we multiplied both things by this. We're going to do the same thing here. Well, anything times 1 is this. So we're going to end up with that starting off. Okay, so we're just going to rewrite this, x times x minus 5. So now if we multiply it to this, I'm going to show the steps just so you're not like, Ms. Gill, how did you go from that to that? Like, come on, lady. So we're going to multiply this whole thing, but remember, you multiply it to the numerator. So it ends up being x times x minus 5 times 8 all over x minus 5. And there is a minus sign. Don't let me forget that. So remember, in the previous lessons, we learned that these are common factors, so I can actually cancel out those, and it would leave us with x and 8. So x times 8 would give us 8x. So now on this side, I would have this. All right, and so on this side, again, we're going to multiply the numerator by this. So what it looks like is we have an x times x minus 5 times 3 all over x. So what can you cancel out this time? We can cancel out those x's. So it would leave us with 3 times x minus 5. I'm going to rewrite it with the 3 in the front just so it doesn't make some of y'all uncomfortable. All right, so now we're going to simplify. So how do we simplify? Well, first we need to distribute here. We need to distribute here, and then we'll go from there. All right, so x times x gives us, well, gives us x squared. X times negative 5, negative 5x, and then we have a negative 8x. And then on this side we have 3 times x gives us 3x, 3 times 5 gives us negative 15. All right, so now we have this quadratic function. So now we're going to have to bring back in chapter 3 and 4. All right, we need to, in order to solve for x, because this square means I have 2 solutions. So I'm going to have to set my equation equal to 0. So how do I do that? Well, I just need to move these to the other side. So I'm going to subtract 3x and I'm going to add 15. All right, subtract 3x, add 15. Now, I do have like terms. So when I rewrite this, I'm going to rewrite it with combining those 3 like terms together. So I have x squared, and then I got negative 5x minus 8x minus 3x. So you could think about that as negative 5 minus 8 minus 3. That's going to give us negative 16x plus 15, and that equals 0, because remember, these canceled out. That's why we chose that. So now we need 2 numbers that when you multiply, you get positive 15, but when you add, you get negative 16. So in order to get a positive product with a negative sum, that means both of your factors have to be negative. So what do we know that you could multiply to get 15 that would add up to get 16? 15 and 1. So we can actually rewrite this as x minus 1 times x minus 15, set that equal to 0. So what are your solutions? So set each factor equal to 0 and solve for x. Oh my goodness, lady, quit pressing down so hard. So add 1 to both sides, we get x equals 1. Add 15 to both sides, we get x equals 15. So our solutions are x equals 1 and x equals 15. Okay, so these last 2 examples, I have some self-assessment questions that I would like for you to try. So if you would pause your video now. This one is like example 9. These are like example 10. Please give them a try. So pause your screen and come back and we will discuss them, but please actually give them a try. Okay, so hopefully you gave this a try and you just weren't waiting for my answers to pop up. And some of you may have more work than what I've shown. I skipped a few steps just to save space. All right, so with this one, remember you were cross multiplying. Here, I decided to add 4 to both sides because the 4 was negative, so I just didn't want to deal with the negative. If you subtracted 5 and got a negative 4x or negative 9x, that's fine. You would have ended up with the same answer. Remember, do not turn a fraction that's a repeated decimal into a decimal. So this one needs to stay a fraction. Okay, if you turn it into a repeated decimal, stop doing that. All right, and then the ones with your least common denominator, so it was 5x in this one, 2x times x plus 1 in this one, and then this was like the first example, part A, that was like part B. Okay, so moving on, we have solving equations with an extraneous solution. So we've dealt with this extraneous solution part before. With a previous lesson, I think it was in chapter 6, one of the lessons we did together, where we get a solution, but when we plug it back in, one of them doesn't work. So that's kind of the idea here about solving with an extraneous solution. So this is where it comes in that you have to check your answer. Okay, so our first step, we need to write each denominator in factored form. So this one's the only one that's not factored out. So we're just going to rewrite it, but rewrite it with this one in factored form. So, okay, so all I did was factor out this. This is the only thing that changed. This became that. All right, so now we have to multiply by our least common denominator. Well, what is our least common denominator? We have an x plus 3 and an x minus 3. So in this case, our least common denominator is going to be x plus 3 times x minus 3. And so we're going to do that like we did our previous examples where we multiply this to each term. So go ahead and set that up now. Okay, so now when we're multiplying this, so I showed you before how multiply this by the whole numerator, then you're able to cancel it out. So we can actually go ahead and look at this thinking of it as a diagonal way. So thinking like this is extended. Oh, green pen doesn't work. Try a different color. Like this would be extended. So if that was extended, we know that this and this would cancel out because they're the same. So that would leave us with just 6 times x plus 3. Okay, so this is taking us back to the previous lessons. And then if we do the same over here, we extend this, what is going to happen? Well, this one and that one's going to cancel out. That one and that one's going to cancel out. And so we're just left with the 8x squared. So then we do this one over here. Remember, we have a minus sign, so don't lose the minus sign. And then we can cancel out the x plus 3 and the x plus 3. So we're left with 4x times x minus 3. So now we have no more fractions for all you fraction haters out there. So now we need to simplify. So we're going to do distributive property. So go ahead and do distributive property. All right, so you should have something like this. So now because we have x squared, we know we have 2 solutions. Well, first, before I do anything else, I'm going to combine my like terms that are over here. So I'm going to end up with 4x squared plus 12x and then 6x plus 18. So now we need to set it equal to 0, right? Set equal to 0. So how do we do that? Well, we subtract these. So we're going to subtract 4x squared. We're going to subtract 12x. All right, so I got minus 12x here. I have nothing to subtract the negative 4x squared from. You know what? Actually, I'm going to do this the other way because we don't really want a negative 4x squared in our answer. So I apologize for not noticing that sooner. So let's actually move everything to this side. So let's subtract 6x and subtract 18 because we want to avoid having a negative x squared at all times. So we got negative 6x here and minus 18 because there was no number up there. So we'll just say it like that. Okay, hopefully that didn't confuse you. If you have questions, please ask in class. So we're going to bring down our 4x squared. We have 12 minus 6 gives us positive 6 and negative 18. All right, so first thing, you ask yourself, can I divide everything by the same number? So in the factoring, we factored it out, but because we're solving, we can actually divide it out. So can we divide everything by a number? So maybe not 4, but I know I can 2. So we're going to divide everything by 2. And I do it on this side, guys, just to show you that we're still doing it here. If you do something on one side, you do it on the other side. The only difference is you always get 0. So then this becomes 2x squared. This becomes 3x. And this becomes minus 9. All right, so now we need to factor more. However, we have an a value. So remember, we have to multiply your a times your c. So we need 2 numbers that when you multiply, you get negative 18, but when you add them, you get positive 3. So if you said 6 and 3, you are correct. So we got positive 6, or negative 6, negative 3. My apologies. What? No, that doesn't work. Hold on. I had it right. positive 6 because 6 times negative 3 does give us negative 18. 6 minus 3 gives us positive 3. So the factor by grouping, remember, you're breaking up this middle term. Some of you still struggle with this, and it's okay. I will, again, help you as much as you need it. So we're breaking up this positive 3x as 6x and negative 3. So then you have to do your factor by grouping. So we're going to factor those two out. So what does the first two have in common? Well, they have an x, but they also have a 2. So I'm going to factor out 2x, and that leaves us with x plus 3. All right, so remember, if we have an x plus 3 here, we have to have an x plus 3 here as well. So what could we factor out to make this true? We could factor out a negative 3. So negative 3 times x gives us negative 3x. Negative 3 times positive 3 gives us negative 9. So now remember, this is one factor. So one factor is the 2x minus 3. The other factor is what's inside parentheses. You only write it one time. So I'm going to have to, as you can tell, I've run out of space here, so I'm going to move it up here. So we now have 2x minus 3 times x plus 3, and that equals 0. If you want to keep the 0 on the left side, that's fine. So now we're going to set each side equal to 0 and solve. So we have 2x minus 3 equals 0, and x plus 3 equals 0. Well, this is the easiest one. I know that's negative 3. This one I got to move the 3 to the other side, so I get 2x equals 3, and then I still need to divide by 2, so I get x equals 3 halves. If you need to put that as 1.5, go for it, because at least it's not repeated. All right, so we have solved, we've gotten these two as our answers. However, the title said with extraneous solutions. So what does that mean? That means, do both of these solutions work? So what we have to do is we have to take these two, plug it back in to our original equation, and see if it works. All right, so I'm going to actually flip my page over to do this just so I have more space. But you're welcome to write it on this side if you don't write as big as I do. Okay, so I've taken the original equation, and everywhere there was an x, I plugged in 3 halves. Now, because I know some of y'all are fraction haters, you can turn this into 1.5 if it makes your life easier. All right, I probably would myself just because it makes it easier to put in the calculator. All right, and then I did the same thing, but with the negative 3. So if you work this out using your fractions, because that's how I originally did it, but like I said, putting 1.5 is perfectly fine. So your answer for this part may look slightly different. I would get this. So this is numerator, your fraction is denominator, just because we had those in the bottom. All right, and then if you actually simplify this, again, you could put it in the calculator or you could save time, make it 1.5. But for the people who don't mind fractions, just going to put it out there and you would get this. Well, you may get a repeated decimal for this part. I don't know. All right, anyways. So we got negative 4 here. And then these are alike, so I can subtract negative 8 minus 4 gives me negative 12 over 3. So negative 4 equals negative 4. So this solution does work. Okay, so x equals 3 halves is a solution. So now let's look at the same thing, but with negative 3. All right, so if you work this out, you would get something like this. So what happens when we have zeros? If you plug this into your calculator, you would get an error message because this is undefined. All right, remember, we cannot divide by zeros. So because of this, we're not able to go any further. So this one would be an extraneous solution. So even though we got it as our answer, when we plug it back in, it does not work. So the only solution is 3 halves. All right, so that is the only solution. All right, so because I know some of you guys like your extra credit, I'm going to give you some here since this video is 25 minutes. I didn't mean to make it that long, but that's what happens when you're having fun. All right, so this will be your extra credit, these self-assessment questions. So turn them in on a separate sheet of paper so I can grade them and give you credit. All right, well, I will see you in class.